Hey, welcome back to Top Agent Training. I am Kurt with Specs Over Coffee. We're going to spend a few minutes talking about radon, which there is a ton of misinformation and misconceptions about radon. And so, first of all, start at the end. How do we test for it? So we have these machines. This is the best way to do it. I wouldn't recommend the charcoal canisters from a lab. They take forever. They're a pain in the butt. Labs usually have weird hours. But for about $1,000, $1,500, you can get a machine that takes a test. It's actually called a short-term test, but for all of us, it kind of feels like a long time. And basically, we leave the test in the lowest level of your house for 48 hours. It takes a sample once an hour, and then it gives us the average measurement. Now, the measurements are made in picocuries per liter. You don't have to know what that means. It's just a term of measurement. And it's basically like how much radon is in, like, a liter of air. So where does radon come from? There's a lot of people say a lot of things. It only comes from one thing. It comes from the depletion of uranium. If you want to look this up, I'm not going to cover it here. The reason certain materials are radioactive is because given a certain amount of time, they give off either a beta, an alpha, or a gamma, and then they actually change. So uranium-241 changes to uranium-239, and then it goes through all these different things, thorium and a couple others that I don't remember off the top of my head, and eventually it turns into radon. So what that means is if I had a pound of uranium right here, and I had 4.3 billion years, after 4.3 billion years, I would have a half a pound of uranium, because it literally, half of it would have turned and gone down the chain into something else. So eventually, this radon is this odorless, tasteless gas, and basically, because it's a radioactive gas, think of it, the best way to think of it is like it's sunburn for your lungs. So if you breathe radon in, and it gives off that alpha is damaging the cells inside your lungs. So the easiest explanation is a sunburn for your lungs. So the limit in the US where they recommend a mitigation system, which I'll talk about what that is in a second, is 4 picocuries per liter. But the EPA has also put out that you should consider a mitigation system between 2 and 4 picocuries per liter. So 4 is kind of the hard number that they use in real estate. But 2 to 4, you should still consider it. And again, when I teach longer classes about this, the thing I tell people is like, look, when you go to the beach, you might have sunscreen, you might have an umbrella, you might take some time in the shade, you might get in the water, you're gonna take multiple levels of precautions to make sure you don't get sunburned. Well, I actually tan pretty easily. I'm part American Indian. And so I don't get overly concerned about all that stuff. But I have relatives that are as white as a ghost, and they really got to worry about that stuff because they do not tan at all, and they burn. So everybody has a little different response to that. Now, a mitigation system, I want to stick on the 4 for a second. Totally arbitrary, okay? Canada, the limit is 5 picocuries per liter. I think Finland is like 11 picocuries per liter. You can Google it, and all the countries have just kind of made up what their number should be. Again, it's a personal choice for you. You probably just want to keep that number as low as you can. And it is what it is. So the problem with radon, because I was telling you it damages your lungs because it's radioactive, is it is actually the second leading cause of lung cancer behind only smoking. And then if you have smoking and radon, now your lungs are really fighting an uphill battle, and over a long period of time, it might not work out so well. And here's the thing, it's very inexpensive. First of all, it's $150, $200 to test for it. And if the levels are high, it's usually like under $1,500 to mitigate it. And usually what they're gonna do is they're basically just circulating the air. So I told you it's a gas, it comes from uranium. Depends how much uranium is under your house. The gas, once it's radon, seeps into your house, and it can turn into, the levels go up. So what they do is they put a fan that sucks air from underneath the house, puts it outside and up and out, and that's it. So as long as the pump is running, usually that's all you need to do. Now there's some, I was telling you misconceptions. Some people think it's only for basements. Some people think this, some people think that. Let me tell you, it can be anywhere, but I am gonna show you this. This is the EPA's radon zones, okay? So if you could see that, this kind of makes sense, you know what I mean? They still mine for uranium, obviously. Most of Colorado, Arizona's like a level 2. You can see some, Florida has level 2 and level 3. A lot of times, if the rocks that contain the uranium are so far below ground that they don't become an issue. But I'm gonna give you an example. I have a friend of mine that runs large apartment complexes in the Orlando area, and you can see here Orlando's like basically a zone 3. So like, why would anyone ever test for it? They built some buildings 5, 6, 7 stories tall, and basically they did all this testing, and they ended up with radon levels on the 4th floor, 5th floor, 6th floor that were higher than they should be, and they just spent like $300,000 doing radon mitigation for this, whatever it is, like 200-300 unit apartment complex. And the reason behind that is simple, right? The way that the building got constructed allowed for air to come from under the ground up into the building, and it wasn't just about being on the first floor. It was all the way up 4th floor, 5th floor, 6th floor, etc. And so that's why we just say, hey, listen, again, our job is to help you not inherit problems unknowingly. So if you want to know about this, we test for it, and it's very simple. Again, it's kind of like going every year and getting your blood work done which costs $100, $150, $200. But those are the basic principles around radon. A long-term test is going to be like 90 days-ish. So the short-term test is 2 days. Oh, one little thing, you might actually look at your radon report and do the math on it and be like, it doesn't add up. Like, I'm doing the math on the 48 hours, and the number I'm getting when I average all of them out, this is for my engineering, for any of the engineers that are watching this. The reason behind that is because the radon machine was in my garage, it was in my office, it was in the back of my car while I was driving to your house, and then I set it up. So what happens is the first 4 hours are actually just a calibration of the machine and don't count towards the 48-hour calculation. So actually, the 48 hours average is only of the 44 hours, the final 44 hours of a 48-hour test. That way we know that that's only the air's not being sampled from anywhere else, like the back of my car or my office or anywhere else. Okay, that's everything you want to know about radon. We will see you on the next training.